Thank you for joining us. CleanPower Worldwide provides environmentally responsible solutions for mechanical and electrical systems. CleanPower Worldwide believes in increasing the lifespan and reliability of systems and equipment. This will lead towards a lower carbon footprint and environmental impact while reducing downtime and costs. One of our great products that will aid in prolonging and protecting electrical systems is our CleanVolt surge protection. CleanVolt has been providing superior power protection for the last 25 years with its patent technology that is outperforming competitors. This presentation will be performed by Justin Mine, Director of CleanVolt. He will cover how CleanVolt performs and its many benefits. We appreciate your time in viewing this video. If you have any further questions, please reach out to us by email or phone.
And yes, thank you everyone for taking time out of your busy schedules to join us on today's webinar. So regardless nowadays of how your power is generated, proper surge protection is essential in making sure that your sensitive electronics reach their proper intended life cycles and that your efficiency is up to par within your system and not suffering from the negative effects of energy surges that we find compounding on quite the basis nowadays, and they seem to be increasing tenfold as years go on. Throughout this presentation, we're going to touch on a few different aspects. Feel free to write down any questions that you may have, and we'll do our best to address them with you. So again, we appreciate your time, and we'll get started here. So this presentation is entitled The New Era of Surge Protection. Energy surging is a growing problem nowadays. Most people think about surge protection. The first two headings are usually what comes to mind for people when they're thinking about protecting themselves. There is three main types of surge, and we'll go over each one of them quickly. So the first one would be lightning, and the second one is utility events. These are both massive types of surge events, and most people, when they think about surge protection, they're thinking about these types of events. But the third and less known about event that we'll also discuss today is internally generated surges. So the difference between the two, or the three, is that the first two occurrences are a high rise in voltage that are caused by either a lightning strike or some sort of mishap with weather or accidents on the utility grid. And of course, the third one is more based on energy surges that are created by voltage drops when your equipment turns on, or when your electronics are doing their normal thing due to their switching power supply. They generate a lot of harmonics, and of course that deviates the voltage waveform and creates energy surges. So we're going to go over an example of each one of these items. The first video here is of a lightning strike. As you can see with lightning events, they're very quick. It's a lot of energy all at once. Like in this video, the Canadian Electrical Safety Authority states that 80% of lightning-induced damages come in through your main service. That's usually due to a strike somewhere in your general area. But of course, lightning events are fairly rare. It's not uncommon to have a room full of 50 electricians, and we'll ask them by a show of hands how many of you have customers that have been impacted by lightning in the past. And it's very typical to see less than 5 hands go up out of that room of 50 electricians. So it is a very damaging event, but of course they are rare. The second one we're going to go over is utility events. In this picture, you're going to see that a lady has, or someone has hit a power pole here. And I'll share my driving jokes for another day, but you'll see what kind of impact that this has on this system. As you can imagine, if your home or your business is connected to this grid at this spot during this accident, your system is getting pounded with energy surges. Of course, this can be caused by line slaps on windy days or ice storms. Animals, we've heard lots of stories of animals up in a transformer causing a short, creating damages in connected businesses below. accidents like in this video, and of course utility events, they're also rare, but we're finding that they're a lot more common than lightning events. As our grid continues to grow and we have more demand on the grid, and we also have more green energy solutions being tied into the grid, we're finding that utility events are becoming more common than they were, say, 20 years ago. The third set that we'll go over is internally generated surges. On your left-hand side, you'll see that there's a power panel. And of course, this load center, all the connected devices on it are sharing the same common power source. And as devices turn on and turn off, or your electronics are on, creating harmonics, the energy surges caused by these actions are being felt by every device shared on this load center. On the far right-hand side, you'll see a university study where they've determined occurrences per hour based on the size of the facility. So for instance, in a small office, you could be experiencing up to 9,000 energy surges per hour. In a manufacturing facility, you could have just under 500,000 occurrences per hour. You have to keep in mind, these are not twice rise peak and voltage events. These are energy surges being caused by load switching and harmonic distortion on the waveform. So I know these numbers seem rather high, but you have to keep in mind that compared to 20 years ago, we're utilizing a lot more electronics when it comes to our automation and our efficiency strategies. And these electronics by nature create harmonics, deviate the voltage waveform, and cause energy surges to be created. In this video, we've got a gentleman that has an oscilloscope hooked up. He's going to show us what he's referring to as dirty power. He'll explain what he's doing in the video, and I want you to pay close attention to the harmonic order levels on the top graph and that red fuzzy line there on the bottom, and watch the changes.
I just turned the inverter back on, the solar inverter, and it takes a couple minutes to ramp back up. But as you can see, we have about 300 to 800, 300 to 800 on the dirty electricity Stetzer meter. Okay, so the inverter just kicked back in. So what we're finding is the inverter creates dirty electricity, but so do all the other homes in the neighborhood.
Of course, the reason that he's saying that the inverter creates dirty electricity is any electronic that's creating a harmonic is creating energy surges due to that impact. And people like to refer to that as dirty power or energy surges. And I found it more interesting how he ended that video with the inverter creates dirty electricity, but so do all the other homes in the neighborhood. Just like the panel that we looked at on the previous slide, and we talked about that sharing the common power source, we are all connected on a grid and sharing power with our neighbors. So a lot of times, depending on where you find yourself on the grid and the way that your neighbors around you are using their power can have a significant impact on the type of power quality that you're experiencing right out of the gate. For instance, when we do these shows with electricians, it's very common that they will put LED lights or automation strategies of a specific brand name into a customer's facility and never have reported any issues with that equipment. They put the exact same equipment, same brand name, mostly everything's the same, going into a different facility and maybe a higher industrial end of town, and weekly the phone calls roll in with complaints about programs stalling, hardware failure, you name it. And a lot of guys have usually scratched their head over the years wondering, well, I've put this in other areas and had great success. And a lot of times it's not about the equipment that's being deployed, but it's rather about the environment in which it's expected to be operating in. So it's important to keep that in mind. So common causes of dirty power are, of course, electronics that manipulate the 60 hertz signal or nonlinear loads. Light dimmer switches are known to manipulate the voltage up to 1,000 times per second in order to get the dimming effect that you're requesting. LED lighting It's electronic in nature. Computers and laptops, printers and scanners, TVs, VFDs are notorious for creating line noise. It's almost like a double-edged sword because you're taking a usable AC current, converting it to DC, and then you're creating a new AC current that you're looking for your application. Multi-speed fans, battery charging devices for phones, tablets, and electric vehicles, and high-efficiency motors. Renewable power systems like wind and solar as well. Of course, these electronics all have switching power supplies, and this problem is getting worse every day due to the impact on the grid and to each individual service. Of course, all this technology is great to utilize, but it's about creating the proper foundation for the long-term success of these items and being sure that there's no negative residual effects building up due to all the energy surges that these devices are building. We like to share these 3 white paper theories. The reason being is twofold. One is to bring attention to the type of surges that are happening nowadays and what the majority of them are accounted by. And the second being that these energy surges, not only do they impact your lifespan of the connected devices, but they can also have negative effects on the efficiency within your system. In 1977, there was a white paper theory that was introduced that was claiming that energy surges were having an impact on efficiencies. At the time in 1977, we didn't have the equipment to test out the theory. It had not been proven. But by 1984, the second white paper in the middle was another engineering firm that set out to disprove this theory. And they actually turned out that they proved the theory. They even came up with numbers like 42,000 energy surges per hour could account to an efficiency in the system of up to 12%. In layman terms, energy surging creates heat. Heat leads to resistance. When your equipment has to strain and your conductors have to strain to pass the same amount of power being requested, it can lead to inefficiencies. Of course, there's technical conversations we can have around this, like skinning effect of conductors, over magnetic saturation of iron core devices or transformers. But of course, we can address those with individuals if they have those questions. The far right-hand side is a Nema white paper study that was released in 2017. What they did is they took a bunch of different electronic components, different styles of lighting, computers, circuit boards, UPS systems, you name it, and they subjected them to what they were calling moderate surges. All these surges were found within the fundamental waveform, and in every case, whether it took them 40 hits or 800 hits, they were able to degrade the components on the other end of the test bench. And the conclusion of their study was that lightning and utility events are very damaging and should be protected from, but they are rare in comparison to the moderate surges that are plaguing our modern systems due to the nature of electronics and all the switching power supplies and all the different loads turning on and off. Because of course, energy surges are much more prominent in a system than voltage surges. You can hook a meter up to a service for a year and you might get lucky, or depending on how you look at it, unlucky enough to record 1 or 2 twice rise in peak voltage situations within that system. But there's energy surges happening constantly and they're found on the current waveform. So it's important to keep these 3 white papers in mind. If you want to read the full versions of the 1977 or the 1984, our CleanVolt.com webpage on the home page, there's a misconception of energy savings tab. If you click on that tab, there is actually links that go to the full version of these white papers if you'd like to check them out. So we come to one of the more important slides during this presentation. If there's one thing you remember from today's presentation, this should be the slide that you remember. And the reason being, so we're showing a 120 volt sine wave here. Of course, the peak to peak is 330 or 169 half cycle. And the reason we like to share this is where you see the blue line at the CV clamping. This is where our manufacturers, if you open up their owner's manuals, they will typically have disclosures in their owner's manual that states that the device has a 10% tolerance of RMS level, and that this is the safe zone. So if it's a computer and it's running off of 120 volts, they're saying that 132 volts is the safe zone of that connected computer. And that, in mind with 80% of the surges are found within the fundamental waveform on the current waveform, it's important to keep in mind that when you're picking surge protection, there's a regulated term that is tested for when it comes to the performance of these devices, which is VPR, which stands for voltage protection rating, or clamping. You can even look it up on Google if you'd like, what is VPR or clamping, and it will give you a 2-sentence answer about this being the level at which the surge protector wakes up and reacts to a surge. So if our manufacturers of our equipment and our electronics are suggesting a 10% tolerance of RMS, and Nema is stating that 80% of surges are found within the fundamental waveform, it's important to have surge protector that has the levels and the ability to be able to address those energy surges that are common in your system and keep the connected tolerance levels that are suggested by the manufacturers as close as possible to those levels, if that makes sense. So of course you can find that on spec sheets for these surge devices, and feel free to take a look. The average we find the VPR is on most 120 volt levels are anywhere from 400 volts up to 900 volts. With CleanVolt, we start to react at 132 volts. This does not mean that we're constantly clamping, because we are geared to see a 60 or a 50 hertz signal, but once that signal increases in nature, we start to conduct and attract that energy surge to our device so that it can't affect any of the connected components or create any type of residual effect that's going to have an impact on your efficiency. So the concept of a surge protection device, of course, is to protect your system from surges. When it comes to lightning and utility events that have a significant amount of energy that may want to enter your system, your main breaker or overcurrent device reacts too slowly, usually allowing cascading damages. When it comes to moderate surges within our system, our connected equipment, while performing their normal function, create energy surges within the peak-to-peak waveform, resulting in interaction between the connected devices. We like to refer to this as F by 1,000 cuts. So the current problem with metal oxide varisitors is that, one, when it comes to major surges, they have not proven to have the ability to, by your main overcurrent device, the valuable fractions of seconds required to disconnect you from the incoming event. And when it comes to moderate surges, because they react at 2 to 3 times peak voltage, they're having little to no effect on the actual surge dynamic happening within the peak-to-peak of the waveform. So the CleanVolt difference, we've now been in the market since 1998, so we're in our 22nd year. When we were originally designed and certified, we done so as a lightning arrestor. The reason this is important to keep in mind is because it shows that CleanVolt has the ability to handle large catastrophic events, and as long as we don't expire our KA rating within a very short period of time, less than a second, we survive to protect in the exact same manner on the next event. When it comes to these types of listings, they usually throw 8 to 10 major occurrences at your device at the end of the test bench, and if it's still not in operation by the end of the last event, you cannot be listed as this type of protection device. It's important to keep those things in mind. When it comes to CleanVolt, we have the highest instantaneous KA value in the industry. KA value when it comes to surge protection devices is the amount of energy that that device is able to handle. I'm going to use our single phase unit as an example. Our single phase unit is 10 kA as our rating. And you can find competitors that have a 25 or a 50 kA rating. Now, to most people, and even to myself, if I didn't know the differences, I would think right out of the gate that the 25 or the 50 kA was a much better value than 10 kA. But the thing to keep in mind is that there's a big difference between CleanVolt's instantaneous 10 kA that's available to your system at the snap of a finger. If that's not exceeded within less than a second, the same 10 kA value is available to your system in its entirety on the very next hit. Whereas with the other devices that are using multi-stack elements to achieve their 25 or 50 kA rating, unfortunately, that entire rating is not available to your system all at once. These ratings are in series per element as they pop down the board. So in most cases, it's 1 kA that's available to the system each time. And as these events happen, it degrades that overall kA value. Eventually, the red light indicator will come on, indicating to the consumer that their surge protection device is now offline. So of course, you're better off to have a smaller kA value that's available every time and does not expire unless that's exceeded, than another device with a higher kA value that can't be achieved all at once and is degraded as these events happen. CleanVolt also has the fastest connected reaction time in the industry. This is verified by the independent labs that test these devices. And when we sent our device away for testing, we felt that rather than testing at the component in the lab like a lot of our competitors do, we wanted to test with 6-inch leads connected to our equipment so that it gave more of a real world speed number. And our device with 6-inch leads or less reacts in less than 1 nanosecond. Our competitors will boast a 1 nanosecond reaction time as well. But you have to keep in mind that that is at the component and before mandatory fusing is added or the lead length is added to connect it into your system. When it comes to major surges, CleanVolt has a robust nature to attract these catastrophic events, buying your main breaker the valuable fractions of time needed to properly turn off with limited cascading damages. But when it comes to moderate surges, CleanVolt's Varisitor actually participates within the fundamental waveform, removing damaging surges that are caused by this interaction. The benefits is that every second of every day, the CleanVolt is cleaning your dirty power while waiting for that major surge event to happen. After about 15 years in the market, you have to keep in mind that we entered the marketplace as a lightning arrestor. Due to our ultra-low clamping ability and the way that we're addressing energy surges, over the years, we started to find out fairly quickly from the feedback from our customers that there was much more to this device than just being able to protect from a lightning event if that were to happen. We gathered that data through feedback we got from our customers and testimonial letters that people had wrote us. And for the first few years, we were even scratching our heads, wondering, well, how is that possible? You must have put something else in your system. But after a while, and enough people give you the same feedback, you start to wonder there must be something behind this. So we started digging deeper into the types of impacts that these energy surges were having. 5 years ago, we invested in a Dranitz data logger. If you were to call 10 out of, if you were to call 10 power companies from coast to coast and request some power quality analyzation at your facility, 6 to 8 out of those 10 power companies would show up with a Dranitz meter. And there's a reason for that. It's a fantastic meter. They do a lot of great calculations in the meter, but more importantly, the sampling rate is very fast. Now, when you're looking for energy surges that are acting within a nanosecond of time, you have to have a very fast meter in order to be lucky enough to record these events. So 5 years ago, we invested in one of these meters. and went out to a customer's facility that operated a commercial laundromat. This was actually on a 100-acre facility here in Alberta that was losing an $800 circuit board every 2 months. The situation had been going on for about 3 or 4 years, and the customer had had experience with CleanVolt in other facilities that they had operated. So they gave us a call because they found out we had this meter and asked us to hook it up so we could see why it was they were losing this board every few months. And as you can see in the waveform information, the waveform on the left-hand side shows the before test that we did. As you can see, this is a 120/208 system. Now, one of the perimeters were stacked within their perimeter where it should be at 120 volt. And the sine wave looked very sick. It was not symmetrical at all. As you can imagine, for a piece of sensitive electronics like a circuit board, it's not designed to live in a world like this. And we could see clearly why they were losing a board so often. And we also noticed that there was 30 volts on the neutral. This indicated to us that there was a wiring condition. We did find out that this run that went to their laundry was an underground cable that was buried in 1980. So it was about 25 years old, or 35 years old, sorry, at the time. So there was a good chance that some rock or something has penetrated the sheath, and it's actually caused this bleed from one of the phases onto the neutral. Without addressing the wiring condition, the CleanVolt unit was installed on this service. And we went back later to test after the time had went by, allowing the system to naturally restore itself and some of these residual negative effects to be worked out. And as you can see, the sine wave was now much more symmetrical. Its peak to peak was more proper. And each one of the phases were laid right within their perimeters at 120 volt where it should be. We also see on this paper here that the neutral was now down to 0 volts. But I'll share the time plot with you on the next page, and we'll discuss a little bit more how you can tell that the wiring condition was still present. And of course, the customer was advised that he needs to address that wiring condition immediately. This is a time plot for the same test. I'll draw your attention down to the neutral on the right-hand side. It's the fourth one down that's gray. Typically, when you're doing this time plot, that neutral should show a straight line on 0. But as you can see, the range is 0 to 1.5 volts. And you can tell that the neutral's trying to jump up. That should be a straight line at 0, but because that condition, that wiring condition is still there, you can see the neutral energy trying to jump up. But CleanVolt has a bi-directional capability. We're not just seeing the hot phases coming in, we're also seeing the neutral and attracting any energy surges that are above the normal RMS frequency that shouldn't be in the system. We attract to our device. So this is a good indication of that on this time plot in the after test. On the left-hand side, in the before test, near the bottom, we have our power factor levels. The worst power factor level calculated during the testing was 0 to 0.5. And in the after testing, we had bumped that from 0 to 0.5 to 0.25 to 0.75. Now you have to keep in mind that CleanVolt is not a capacitor. We cannot increase power factor from what the calculated median is determined to be. But you have to keep in mind that as those white paper studies we went over that you can review later if you wish, they clearly indicate that energy surges have a negative impact on efficiencies. And power factor is really just the degree of separation between your voltage waveform and your current waveform. 90-degree separation is a 1. As energy surges build in a system and it creates negative effects with skinning effect in the conductor, etc., and eddy currents start to build up in that conductor, blocking the natural flow of energy, it creates a lag between that current waveform and the voltage waveform. And the further the current gets from the voltage, the lower your power factor drops. So that's why it's very common to find people that have a calculated median of, say, 88 or 90 for their power factor, but they're operating in the low 80s. A lot of times, if there's no other reasoning for it, it's coming down to the energy surges and the negative impact that has on the system overall. So just keep that in mind when it comes to CleanVolt's not there to enhance your power factor. It's there to remove the root of the problem and make sure that your median power factor is being achieved. If you require further enhancement of your power factor, you should be using capacitance. And of course, we can have discussions about that if anyone would like to dig into it further. The last studies that I wanted to share on this same particular reading was harmonic time plots for this study. We found that in the before test, we had the third order of harmonic on phase A, almost up to 12.5 volts. We found this interesting because being a laundromat and the type of equipment that is present here, the third order of harmonic should not even be present in this situation. But what we found over the years is that harmonics are typically generated a few different ways. Mainly they're generated by the electronics that are running, and depending on what it is that's operating, they will create a harmonic. But what we're finding is that when those harmonics and the energy surges come back to the power source and start to mingle and interact, it can create what we're calling a phantom harmonic. In this case, we know the third order of harmonic in the before test was a phantom harmonic because no equipment should be emitting that order of harmonic. And the reason we know this is because when we did the after testing, as you can see on the right-hand side, the third order of harmonic was almost wiped off the chart and now down at a level of 0.02 volts rather than 12, just under 12.5. And the reason this happened is because when we removed the energy surges from the equation, it calmed down this order of harmonic that shouldn't be present. And of course, you can still see there's some order of harmonics. I think that's the fifth order of harmonic, just around 2.5. The 7th order and the 11th order are the three most prominent orders in this after test. But there's equipment within this facility that are generating those harmonics. And if, say, these levels were above 519 standards, then you would probably need a harmonic filter to address those. Keep in mind that harmonic filters are also beat up by energy surges. This is why they have usually a 10 or a 5-year warranty when you buy them. But CleanVolt will address the energy surges caused by the harmonics, therefore eliminating the risk of damage to your equipment and also eliminating the deterioration of the harmonic filter itself. Here are some thermal images that were provided to us by a customer that operated a dairy barn. This was located out of South Dakota, so these are US heat numbers, thank God. They're not 186.5 degrees Celsius, that's a good thing. But they were running about 77 degrees Celsius in the before CleanVolt picture on your far left. CleanVolt was installed near the bottom of this bus on the breaker you can see in the second picture from the left. It's starting to heat up green on the bottom. It's sort of cut off in the picture. This picture was taken 60 hours later by the customer, and we found it interesting that the heat was migrating. Up to this point, when these thermal images were done in 2014, we had been provided lots of feedback verbally over the phone or letters from customers reporting that they noticed a difference in heat on their systems. But this was the first time we had actually visually seen it provided to us by a customer. As you can see, 76 hours later, the heat dynamic on the load center has changed significantly. And the breaker that the CleanVolt is installed on in the bottom right-hand side in the 76-hour after picture is now hot and showing as heat on the thermal image. 156 hours later, after the unit was installed, you can see there is a significant difference in the heat dynamic on this panel. Of course, there is still some hot spots in the panel. It's important to keep in mind that whether it comes to heat damage or whether it comes to previous surge damages caused to components, that CleanVolt nor any other device can reverse damages caused by that energy surging already. what's happened. So this panel in particular, we confirmed with the customer that it had been in service for 10 years, 8 of which under extreme heating condition. It was a ventilation panel, so there's VFDs associated with these fans. And as you can see, that's why there's still heat signatures left on the panel. There's most likely micro fractures that have happened on the bus and behind the breakers, caused by all the energy surges and the heat throughout the years. And we recommend to the customer that they pull their bus out, replace the bus, and even replace any breakers that have been subjected to this heat for anything longer than a year. So this stuff's pretty interesting too, and another benefit you can keep in mind, depending on whether or not you experience that sort of issue in your facility. Over the years, we've had a ton of different testimonials provided to us by our customers. On our website, under our newsletter tab, there is a 4-year catalog of monthly newsletters that we released between 2012 and 2016. Each month, we tried to touch on a different electrical concern and couple it with a relatable customer testimonial that had a positive benefit out of the same concern we were touching on that month. Feel free to visit our website, cleanvolt.com. There's a lot of great information on there that we've gathered over the past 22 years while we have learned, and we continue to learn every day. And we're excited to work with anybody who wants to reach out and have any questions or requires any support. That being said, I'd like to thank everyone for putting up with my blabbing for the last half hour or however long it's been. And at this point, does anyone have any questions?